Again, to recap on page 7, Garrett, hush. Kyle, hush. To recap on page 7, the coefficient tells you how many moles of each chemical are found in the reaction. So these coefficients here are all numbers of moles. So when they ask how many moles of oxygen gas, you look at the coefficient and that is your answer. 3 moles here, 3 moles there. When they ask how many moles of carbon dioxide, you look at the coefficient, it says 2. That means 2 moles of CO2. That is your answer for part B. And the same for C. How many moles of water? Look at the reaction. The coefficient is a 2, so that's 2 moles of water. They ask how many moles of ethene, C2H4, Kyle, hush. They did not have a number written there. If they didn't have a number, that means it was secretly a 1 mole. So that is 1 mole of C2H4. Now, stoichiometry is how to calculate the amount of reactants or products needed in a chemical reaction. This is like using a recipe. Why are you talking over me?
It sounds hard.
It's fine. Hush. No, you're not. You're complaining about the word tasty.
I was.
Hush.
We're excited about the word tasty.
Like tasty food.
Stoichiometry is like using a recipe. Hush. If you are given a recipe, you can calculate how many of each ingredient, each reactant that you need to make your tasty, tasty meal, your food product. Okay, for example, here's a recipe for a peanut butter sandwich. 1 serving of peanut butter, so we can say 1 PB.
Are we gonna make a sandwich?
Then don't eat it.
Dude, let's do a lab about it.
Plus 2 slices of bread. You know, maybe if y'all didn't talk over me, we would consider it.
I hope we do a lab on it.
Yeah, are we gonna make sandwiches? Cause that'd be
Dude, we should do
I
a
would
lab
consider
about
it if you guys would hush for once.
Better Rolex.
Kevin, are you hungry?
And if you combine these together, you can get 1 peanut butter sandwich, which is a PB and 2 breads. In chemistry, we find a ratio of things needed to make our food. For example, we could say that for 1 serving of peanut butter, we need 2 slices of bread. That's a ratio from our reaction. You could also say that for every 1 serving of peanut butter, you could make 1 sandwich. That's another ratio.
Well, but then you would
That's
need
not true.
Then you would, yeah, then you need the bread.
Well,
I have a thing of peanut butter, but I don't have any bread. I can
Okay.
make a peanut butter sandwich.
what we're saying is if you have 1 peanut butter, you have enough peanut butter to make 1 sandwich.
Oh.
That's what we're saying.
Hello.
That's what we're saying. And there's another ratio up here that I didn't write down yet. What's our third ratio we can get from this reaction?
Oh, 2B?
Yeah, 2 bread, you can make 1 what?
PB.
Sandwich, PBB2. Yeah, yes. So those are the ratios we can get from this reaction. We can use these ratios to calculate the answer to questions like number 1 here. And the way we're going to calculate it, that's true, but you got to show your work. You got to show your work. And guess how we're going to show our work? With multiplying fractions. Oh, we're never done with it, no.
We really have to show our work on that.
Yes, you do.
I can't wait to
Okay.
use this in my job.
The first fraction, you're going to take the number they gave you and do what with it?
80 divided by 2?
Not do it.
On the first fraction, you take the number they gave you
1.
over 1.
And then 1.
And that's 80 slices of bread, so we're going to label it B for bread.
We gotta find more bread.
So if there's bread on top, we will also put bread on the bottom.
That's how sandwiches work.
That's true. That was pretty good, actually. Okay, when we are getting it on the bottom, and we want to turn it into... Okay, Garrett, hush. And we want to turn it into peanut butter sandwiches. So that means on top, we're going to put our symbol for peanut butter sandwiches. We need a ratio between bread and peanut butter sandwiches
A lot.
that we can put into this fraction. So did we find a ratio anywhere between bread and peanut butter sandwiches?
2 B and 1 PB with 2.
Yes, 2B. 2 bread, go with 1 PB Batu.
Sorry,
Peanut butter sandwich.
Sorry, observer. It's peanut butter top.
To solve this, 80 times 1 is 80, divided by 2 is 40 peanut butter sandwiches.
Heck yeah.
Yeah, that's a lot of
You're John
sandwiches.
Chicken it is.
Have you ever had a peanut butter and honey sandwich? We should make that.
Dude, those are so. Peanut butter and jelly. Yeah, we did those.
Jelly is gross.
Okay, see if you can show the work for number 2. I want you to silently read number 2 and see if you can figure out how I want you to show the work for that. I'm going to give you 1 minute. See if you can figure out how you're supposed to show the work for number 2. Silently, Cameron, silently. Silently.
No, I'm not going.
Yes.
Yes.
Luis, you are not being silent. Hush. Hush.
Is that a me? RD8? Is it RD8?
30 seconds. Figure out how to show the work. Silently. Hush, my children.
Was it like this?
Yes.
So far.
10.
Oh, I have to put in numbers now.
Mm-hmm.
All right.
Whatever they gave you goes on top over 1.
Whoa.
If we have peanut butter on top, remember that what goes up must come down. So peanut butter is going to go on the bottom.
How sandwich we
That gets rid of our peanut butter, and the other thing they want is bread, so we're going to put bread on top.
bread.
And now we need a ratio between bread and peanut butter. Did we have a ratio somewhere between bread and peanut butter?
1 PB.
Yes.
I'm so good.
For every 2 bread, 2 bread, 2 bread, there's 1 peanut butter, 1 peanut butter. And if you do the math, we end up with being able to use 10 slices of bread.
No. This is so much easier than the last one.
Because we made it a sandwich.
Well, we're not done yet.
It
Okay,
has always been a fraction.
an easy way to figure out these ratios, my children, hush, Luis,
It's always been
Cameron, BJ, whoever is drumming.
He said we're just now starting to do fractions with moles.
I don't care what he said. I want you to not say anything. Luis. An easy way to figure out these ratios is to draw a bridge from one food to the next. Then it points out whatever number should go on your ratio. So if we rewrite our little food reaction down here.
All of that.
All of it? Yeah, there's so much. I'm really worried about whether or not you're going to be able to do it.
Hand is gonna fall off.
This time they're giving us a number of sandwiches and they want to know bread. So we can draw ourselves what we call a little bridge.
Little bridge.
A little bridge
Little bridge.
No bridge.
to help us keep track of our work, that we're starting at the sandwiches and we're ending at the bread.
No.
And if we draw our 2 fractions, hush,
Little bridge.
hush. If we draw our 2 fractions, they said 20 sandwiches is what we're starting with, so we're going to put 20 sandwiches over 1. If you have sandwiches on top, you need sandwiches on bottom. And once we have the sandwiches on the bottom, we can use that coefficient from the reaction. And the arrow conveniently is telling us, hey, start with 1 of these. And then if you follow the arrow, it's pointing to say, hey, you should end with 2 of the bread. It is telling us what to write in our fraction. If we look at the
Does
arrow,
it make 2b every time on top? I mean, like in the equation?
only if you're comparing with bread. You would use 2b every time you're using bread. But like in the number 1 up here, 2b was on the bottom.
Yeah, but we still use 2b. I'm saying we're gonna use 2b.
Yeah, that's only because all of these we're talking about bread. If they had not talked about bread, if they had talked about just sandwiches and peanut butter, we wouldn't have used the 2b.
Are we ever gonna have the fractions where it's 2 again? Or the 3 again?
Oh, we're going to go up to 4 fractions.
Oh my goodness.
Oh, Millie.
Oh my goodness.
Wow.
When you're done writing this, turn the page.
Oh, I'm not done.
When you're done writing this, turn the page.
Don't turn it.
40.
I don't feel comfortable. They're making up.
What?
Kyle,
The restroom, please?
hurry, Cameron.
Alrighty.
No, you can turn it in from here. But
BJ, you get caught up again.
Cameron, while you're in there, check to see if
Oh, whoa.
Or in there at all.
Alright, what if he's not?
Then tell us that he's not in there. No, honey, snitches get.
I bet you about $50
Thanks.
she's not in the bathroom.
We're rather sure.
I bet you 100.
Oh, we're not taking that bet.
I bet you
All right.
150.
There's a little map up here that we're going to come back to on a different day. Okay, we're going to come back to this little map on a different day. For now, I want to move past it. We compare ratios and number of moles. So we call them mole ratios. And that's, again, because the coefficients are telling us numbers of moles. The coefficients are telling us numbers of moles. So we can call these ratios between them mole ratios. For instance, in number 1, if I have 8 moles of oxygen gas, how many moles of water will I produce? We're going to draw a little bridge from what they are starting us with to what they want us to end with. So if you read the problem, what are they starting with us with? They give us 8 moles oxygen gas. Yes. Look at the reaction. Which one of these 4 things is oxygen gas?
3.
The O2, yes. Okay, so we're going to start at the O2. That's oxygen gas. It has a 3 in front of it. And what are we going to point the arrow at? What are they asking us to find? We started with oxygen. What is the other thing they mentioned in this problem? Water. So we're going to draw our bridge from oxygen to water. That's our bridge.
okay.
Okay? Kyle, hush. If I have 8 moles of oxygen gas, so I'm going to need 2 fractions. And it says if I have 8 moles of oxygen gas, so I'm going to start with 8 moles of oxygen. And starting today, we need to label the chemical in our fractions all the time too. I know before I didn't really make you label the chemical, but starting today, you always need to label the chemical. Because in stoichiometry, the chemical changes. And if you're not labeling the chemical, you're going to get lost in your work because you won't know when you're supposed to change the chemical. So, write the chemical every piece of fraction. If you're not labeling it, you're not going to get full credit when you take quizzes and tests. You have to label everything if you want to not lose points. If you want full credit, label all the things. So not just 8 moles, but 8 moles of O2. And then what goes up must come down, so moles of O2 will also come on the bottom.
That man's slumped.
He actually is in there?
I swear.
Okay.
Oh, okay.
Maybe should we send him to the nurse?
Because like when I went in, he was like coming out and he was like scared to get like too far away from the bathroom. 'Cause
Okay. Thank you for.
he was like he was being serious.
Okay.
I know.
Thank you, Cameron. I have a nurse pass. Do you want to fill it out?
Here, I'll go get him. You want me to help? 'Cause y'all can't go in the restroom.
That's true. Let us fill out a nurse pass first.
Garrett, you smart, brother.
Okay. Anyway, continuing. When you get to moles on the bottom, this is important. I hope you're listening. This is important. When you have moles on the bottom, that is when you are ready to use the numbers from the coefficients and follow the bridge. So on the bottom here, we have moles of O2. That means I'm ready to take the number from the reaction. So what number of moles of O2 is in the reaction? 3. So that means I'm going to write a 3 here. This 3 and that 3 are the same 3. I'm taking this 3 and I'm writing it in my math. Okay? And then I follow the arrow, follow the bridge. Think of yourself like you're driving across a bridge. And when you get to the other end of the bridge is telling you what to write on top of your fraction. So it's kind of like the bridge goes from the bottom of your fraction to the top.
Do we have to start coloring again?
We will, but not right this second. The bridge is pointing at 2 moles of water. So on top of the fraction, I'm going to write 2 moles of water. I'm just following this little bridge. Luis, do you have a question?
Yeah.
What is your question, Luis?
So think about carbon fiber, but no, it was a question to get things.
Okay, so if it wasn't about this, do you think you could save it for later, please?
I won't see later on. He's going to a game.
Okay. What about just some other time?
All right.
Thank you. At this point, we're ready to put stuff in our calculator. 8 times 2 is 16 divided by 3
You could go to the game and tell him what.
with 2 decimal places is 5.33. And our answer needs to be labeled. You will.
Everyone makes
Our answer needs to be labeled with the units that were on top here.
I never went.
Okay, Garrett, Luis, do you need to have your own conversation while you're having your own, while you're writing?
Yes, I've been talking.
Okay, I would like you to only write and not talk. Okay, I want you to notice something. If we were color coding, we would have moles, 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 moles. That's interesting because before we used to say you could only use moles how many times? In our old unit, how many times could we use each color? Before?
2.
Only 2. Now we've got 4. Here's a new rule. Starting now. Okay, new rule. Starting now. You got to use moles 4 times. If it doesn't get used 4 times, you did something wrong. Okay? From now on, you got to use moles 4 times. If you didn't use it 4 times, you did something wrong. So I've got it 1, 2, 3, 4 times here.
So the whole equation is going to be moles?
For now, we'll add on some more stuff in a bit, but for right now, the whole equation is just moles 4 times. 2 with 1 chemical, and then you switch chemicals for the other 2. Okay, so keeping that in mind, let's look at number 2 here. If I produce 0.5 moles of CO2, how many moles of C2H4 reacted? And we got to draw a bridge. It's going to start at whatever chemical they gave me a number for. So here's the number they gave me. What chemical is going with this 0.5? What did they give me? What chemical did they give me with it? Carbon dioxide. So that's where the bridge is going to start. And the other chemical in this problem is where it's going to point. So we started at CO2, and it's going to point at what other chemical? What's the only other chemical on number 2? The C2H4. So that's where it's going to point. So for number 2, we have a new bridge, and it's going to go from CO2 to C2H4. It's an underground bridge. I'm not sure if that's still a bridge or maybe now it's a tunnel, but there you go. Yeah, that's true. So it works. It works. Good call. Thank you, Garrett. Okay. So draw your 2 fractions. He asked. Draw your 2 fractions. Again, what goes on top of the first fraction is whatever they gave you, and you need to label the chemical as well and put it over 1.
New rule.
That uses moles once. We need to use it 4 times, so we got to keep going. What goes up must come down, so if you have moles of CO2 on top, they're also going to go on the bottom. And we said a few minutes ago that if you get 2 moles on the bottom, that means you're ready to do something. Do you remember what we said? If you have moles on the bottom, what you're ready to do?
Finish the problem.
How? Be more specific.
I kind of just guessed.
Yeah.
Yeah.
Okay. When you have moles on the bottom, you're ready to take the number out of the equation.
And you got
So since CO2 has a coefficient of 2 in front of it, that 2 is going to go into my fraction. And then I follow the bridge, follow the arrow. And what is the bridge pointing at?
C2H4.
C2H4. How much C2H4?
1 mole.
1 mole. So guess what's going to go on top of my fraction?
1
1 what?
mole.
Of?
C2H4.
Thank you, Kyle. That was very good.
Thanks.
You're welcome. That uses moles 3 times. I need it 4, so I guess I'm going to have to solve this. 0.5 times 1 divided by 2 is going to be 0.25
Whoa.
moles of C2H4. And I know that moles of C2H4 need to be in my answer because I got to use moles a 4th time.
So it's always gonna be moles for now on?
For now, yes, we will also add some more stuff on, but from now on, you're going to have 4 moles in every problem, no matter
So
what.
much easier when it's just moles.
I'm glad you feel that
When
way.
there's all the different stuff, that's what like confused me. It's like when to use like. That's what confused me.
I'm glad you feel that way. You're going to get mad when we get to page 10, but for page 9, you're going to be pretty happy. Okay, can I move my paper? Are you ready?
No, why would you move it? That's page 10.
No, that's page 9.
Oh, never mind.
Okay. This bridge we've been drawing, the arrow, we call this bridge something. It has a special name. It's called the mole bridge. The mole bridge is a toll bridge. What does that mean, a toll bridge?
Hey,
You guys are clever.
You gotta pay. We are clever, thank you. The mole bridge is a toll bridge. You have to pay to get on, and you have to pay again to get off.
no, you don't.
That's a rubber.
That's how toll bridges work.
No, you don't.
Yes, they do.
They do.
No, you cover your license plate.
Then you get like the cops that police the toll bridge. They chase you down, and then they like give you a ticket.
Like a pay bill on your mail.
Yeah,
A pay bill on your mail.
No,
they will mail you a bill, but if you
No, they can't see your plates.
yeah, but if the camera catches a car going through with no plates, then there are cops that only work on the toll bridge, and they will come find you.
I have a button. I
Have you
push
ever
it
been in
and
a
it
toll
covers
bridge?
them.
Yeah, that doesn't sound real.
It's like a-
Anyway, the only currency accepted by the mole bridge toll workers is moles.
Let's go to YouTube.
You cannot pay them in anything. Garrett, hush.
Hey,
Garrett, hush.
No. We don't use the
Promised.
You can, but it's illegal.
Prove you deserve the chair, Garrett.
That's so alive.
Okay, the only currency accepted by the mole bridge toll workers is moles. You cannot pay in anything other than moles. They will not let you on or off the bridge if you try to pay in something else. If you try to pay in grams, no bridge for you. They will make you go back to Canada.
Get off my chair.
No grams.
DJ here.
This is America. We don't use grams here, except in chemistry class, but not on bridges, for sure. Okay, so at this point, you need a calculator, and I'm going to show you a little video. So if you don't